In this lesson, we're going to look at the Newton's second law in terms of momentum. We're going to look at the relationship between the net force and the rate of change of momentum. Let's look at the Newton's second law. What does it say? The Newton's second law states that when a net force acts on an object, the object will accelerate in the direction of the force, and the acceleration is directly proportional to the force and inversely proportional to the mass of the object. Let me just write that. When a net force acts on an object, the object will accelerate in the direction of the force, and the acceleration is directly proportional to the force and inversely proportional to the mass of the object. This can be summarized in this formula. Net force is equal to mass times acceleration. Remember that. Now we want to bring in momentum here. Then how do we do that? We're going to use this formula and what we know about acceleration and momentum. Remember, change in momentum. Change in momentum is equal to mass times change in velocity, which is final velocity minus initial velocity. Then we talked about the Newton's second law. We say that net force is equal to ma. Right. Now, remember acceleration. Remember that acceleration is equal to the rate of change of velocity. So it's going to be final velocity minus initial velocity over change in time. Or even from this equation of motion, remember this equation of motion, final velocity is equal to initial velocity plus acceleration times change in time. If we want to make A the subject here, we can subtract initial velocity on both sides of the equation. Final velocity minus initial velocity is equal to acceleration times change in time. Then we divide both sides by change in time. So final velocity minus initial velocity over change in time is equal to A. Right, you see that. So this is acceleration. So what we do, we replace this A here in this Newton's second law formula with what? With final velocity minus initial velocity divided by change in time. So it's going to be F net is equal to M. Then we replace this with final velocity minus initial velocity over change in time. Okay, right. Now we can multiply this M. Just check. We can bring in this M and say this is F net is equal to M, then final velocity minus initial velocity over change in time. Like we multiply this M with this numerator there. Okay, right. And then what is this? What is this? Do you see that this is what? This is change in momentum. So we can replace this with change in momentum. So we can say net force is equal to change in momentum over change in time. So what do we say about this? Let's put this in words. Newton's second law in terms of momentum states that the net force acting on an object is equal to the rate of change of momentum of the object in the direction of the net force. That's what it says. The net force or the resultant force acting on an object is equal to the rate of change of momentum of the object in the direction of the net force, because say that F net is equal to change in momentum over change in time. This is the rate of change of momentum. This is the rate of change of momentum. So the net force acting on an object is equal to the rate of change of momentum of the object in the direction of the net force. the direction of the net force is always in the direction of the change in momentum. Don't forget that. Let's look at some examples. Example 1. A 5 kg metal ball rolls east from rest on a frictionless surface and reaches a maximum velocity of 10 meters per second in 5 seconds. A. Calculate the change in momentum of the ball. So we want the change of momentum. So we need to identify our positive direction. So positive direction, this will be east. And then what we have the mass m is equal to 5 kgs, is already in kgs. And then what is the initial velocity? Initial velocity from rest. So it means the initial velocity is 0 meters per second. And then what is the final velocity? Final velocity is 10 meters per second. Right, and then what else do we have here? We have the change in time, or time, 5 seconds. Right, so we want to find change in the momentum. So change in momentum is equal to m times final velocity minus initial velocity. So change in momentum is equal to m. Our m is 5, so we put 5 there. Then final velocity is 10 minus initial velocity, which is 0. Right, and then which means that our change in momentum is going to be 5 times 10, which is 50 kilograms meters per second. Right, direction will be east because the answer is what is positive. Now we have the change in momentum. Let's see. B, the net force experienced by the ball. So the net force experienced by the ball, net force is equal to change in momentum over change in time. So we have our change in momentum. The net force here is going to be 50 divided by change in time, which is 5 seconds. Right, 50 divided by 5, and then we get our 10 newtons east. Done. Right, let's do example 2. A biker, 67 kilograms, on his bike, which is 3 kilograms, cycles north at 6 meters per second. A braking force applied by the brakes as well as the frictional force decreases the velocity of the biker to 2.5 meters per second within 5 seconds. Alright, calculate the change in momentum of the biker and his bike combined. Let's choose our positive direction. So positive direction, let's say north. Right, now what information do we have? The mass is going to be the mass of the biker plus mass of the bike. So 67 plus 3, which is 70 kgs. And then do we have initial velocity? It's cycling at 6 meters per second. 6 meters per second. And then do we have the final velocity? Yes, reduces to 2.5 meters per second. Right, and then change in time is 5 seconds. Right, what else do we need here? I think we have all the information. Now let's calculate the change in momentum. A, change in momentum is equal to mass times final velocity minus initial velocity. So change in momentum is going to be the mass, which is 70 kg combined here. This is biker and the bike. And then the final velocity is 2.5 minus the initial velocity, which is 6. Right, and then put this in the calculator. Change in momentum is going to be negative 245 kilograms meters per second. Right, and then since it's negative, it means this will be 245 kilograms meters per second south. Right, opposite our positive direction because it's negative. Then B, we need to calculate the net force experienced by the biker and this bike. So we want to find the net force. So net force is equal to change in momentum over change in time. Like change in momentum, we already have it. So it's going to be 245 divided by 5, which is equal to 49 newtons south.